Completing the square can also be useful for manipulating equations of parabolas into a specific form, so you can easily pick out where the vertex of the parabola is. So let's just kind of recap the equation for a parabola. If I have this equation, y equals the quantity x minus h squared plus k, that's a very nice form because I can easily pick out where the vertex of the parabola is. The parabola, first of all, let's just make sure we know what that is. It's just a curve, right? So here's an equation or a plot of a parabola. Here's another parabola. So there's these things that have a point called a vertex, and about that point they either kind of grow up or grow down. But that's all a parabola is. It's just a shape. And often we would like to know where that vertex is located. If I can turn my equation into this form, it's easy to tell where the vertex is. It's always located at hk. So being able to get your equation into this form is very useful because then I can just write down where the vertex is located. So let's do a few examples of that, and we're going to do that by completing the square again. So we're going to use what we know about completing the square to turn these equations into this form right here. So here's my starting equation, y equals x squared plus 8x minus 5, and I want to know where the vertex of this parabola is. Unfortunately, this starting equation is not in that form, so I can't just write down what h and k are. I need to do some work to manipulate it to be in that form. So very similar to the strategy in the last video, we're going to move constants to one side, complete the square to force it to have this perfect square trinomial format, and then it will be in the format that I want. All right, so let's do that. So let's get rid of that 5. Let's add 5 to both sides. I'm not going to change anything. I'm going to add 5 to both sides of this equation. So I've done that. Now I'm going to complete the square on the right. So b is 8. So 8 over 2 is 4. 4 squared is 16. So I'm going to add 16 to both sides of this equation, which I've done on the left, and now what I've done on the right. This now has been completed, the square, so now I can write that as x plus 4 quantity squared. Again, whatever you have right here ends up going right there. And obviously 5 plus 16 is 21. Now let's go ahead and subtract 21 from both sides, and I end up with this right here, which is now perfectly in that format, just like I desired. I can now look at this and figure out exactly where the vertex is. H is a negative 4, and k is negative 21. So the vertex is at negative 4 minus 21. So if I was to plot this initial equation, its vertex would be 4 units to the left and 21 units down in the xy plane. All right, let's do another example, starting off with y equals x squared plus 4x plus 20. Let's find the vertex of this parabola, so subtract 20 from both sides. Complete the square, so b is 4, so 4 over 2 is 2. That squared is 4. So I'm going to add 4 to both sides of the equation. So I've done that. On the left, minus 20 plus 4 is a negative 16. And on the right, because I've completed the square, this is now x plus 2 quantity squared. I'm going to move this 16 to the right. What I really mean by that is add 16 to both sides. So on the left, that goes away, and then it pops up on the right. And now I've been able to manipulate my starting equation into the form that I want. This looks like the quantity x minus h squared plus k. So h is a negative 2, and k is 16. So this parabola has a vertex at minus 2, 16. All right, that's it for now. Another kind of useful thing that we can do with completing the square in terms of manipulating quadratic equations into a specific form, so it's easy to pick out the vertex of where the parabola is located.